Welcome, everyone. Thanks for tuning in. I'll run through some information that informs best practices around security patching automation. I'll cover various modes of security patch distribution and automation, also the patch distribution infrastructure and how to make air-gapped mirrors. And lastly, I'll cover security patching, or rather security coverage timelines. There are some pitfalls, but I'll point them out so you can keep your devices safe and free from exploits. My name is Rajan Patel. I'm a product manager at Canonical, and I'm responsible for Landscape, a systems management solution for Ubuntu, which can distribute software and software updates, and also inventory and audit software and users. I'm also responsible for Livepatch, a security patching solution for the Linux kernel, which shrinks the window of time the Linux kernel is exploitable from a critical or high vulnerability. Livepatch does this without disrupting the machine and applies the live patches in a manner that does not require a reboot. I'll talk more about those products in a moment. There's more to security patching automation than those two products alone. But before diving into the agenda, I just wanted to review the results of an unscientific poll on LinkedIn. And it seems that 36% definitely wear their seatbelts when they sit in a car. 20% align their security patching with their taco consumption. And 18% are too busy for Taco Tuesday. And 25% are using security patching automation with appropriate reboot intervals, I hope. So this is today's agenda. I'll cover all the big questions: what, where, how, and when. So what patching automation options are available? Where do security patches come from? And where can you distribute them from? So this is relevant for anyone in offline or network-constrained environments and needs to set up internal mirrors. I'll also cover how security patches are distributed and how they should be applied. You may also be curious how Canonical's kernel rolling strategy extends the security coverage window for certain kernels, so I'll thoroughly cover that. And most importantly, given all this information, when should security maintenance events be scheduled? So at any time, feel free to fire off questions or cheeky comments in the chat, and I'll crack those open after I've run through this agenda. And if I run short on time, we will reach out to you with answers. So starting with what patching automation options are available, the automated security patching story for Ubuntu is second to none. Starting with patching automation number one, Livepatch. The Linux kernel has over 30 million lines of code, and it's not uncommon for the stable Linux kernel source code to receive 25 patches every day. And many of these patches address security vulnerabilities, which may or may not be formally disclosed. So live kernel patching is an interim solution for high and critical severity security vulnerabilities in the kernel, and these vulnerabilities need to be addressed immediately. So preferably without any interruption of service on high availability or mission critical workloads. So Canonical's Livepatch solution leverages ftrace and aligns with the upstream Linux kernel's live patching technology. Canonical Livepatch compiles a new function which addresses a security vulnerability and relies on ftrace to redirect calls to this new patched function. So when a high or critical vulnerability is reported, the security team at Canonical publishes an Ubuntu security notice, or USN for short. And your machine's package manager can install the security update, or you can use the profix command to apply the security patch. So the kernel team at Canonical also publishes a Livepatch security notice, or LSN for short. So the Livepatch client on your machine will download available live patches associated with the LSNs relevant for your machine from the Livepatch server, and the machine is going to go ahead and get that kernel fully patched up and ready to go. The LSN and USN for a specific vulnerability are packaged at the same time, but the implementation details for the LSN and USN are different. The LSN will only patch individual functions in memory for high and critical vulnerabilities only, and may contain a subset of the contents in the corresponding USN. So applying a USN patch installs a complete package and will also include other fixes. So moving on to patching automation number 2, snaps. So there are two types of Ubuntu: the Debian-derived classic Ubuntu and Ubuntu Core. So on Ubuntu Core, packages can only be installed as snaps. And on classic Ubuntu desktop and server, packages can be installed using apt and snap. Now, snap is a cross-platform format for application packages on Linux. Snaps are self-contained and dependency-free applications. They run in a sandbox with mediated access to the host system. System access is denied by default, and the system administrator controls what interfaces a snap package is allowed to access. So snaps are secure because they're GPG signed, read-only, and tamper-proof. And snaps are efficient because they're compressed file system images, and they're optimized for decompression speed. So snaps use less disk space because they do not get unpacked or unzipped elsewhere on the disk. Rather, they're just mounted. And snaps use less bandwidth for upgrades because a binary diff for an update results in downloading only the bits that have changed. And snaps are fail-proof because they come with a built-in backup mechanism for any application data and have the ability to roll back automatically if upgrades fail. So snaps have the ability to self-update, but it is possible to control this behavior on a machine-by-machine basis or at scale by using Landscape or a self-hosted snap store. And lastly, patching automation number 3. We've got unattended upgrades. So unattended upgrades is a package that's installed by default on Ubuntu, and it can download and install updates without user interaction. And it can be scheduled through cron or as a systemd service. Unattended upgrades only installs packages from configured apt sources and does not interact with snaps or Livepatch. It can check for depackage prompts in the event of configuration file changes when upgrades are performed, and all operations and depackage package manager outputs are logged locally on the machine. So unattended upgrades provide some sensible but configurable defaults. You can configure unattended upgrades to continue or halt unclean or interrupted depackage exits, and also send email alerts. It can also queue installations to occur during the shutdown sequence, instead of as a background process while the machine is in use. It can remove unused kernel-related packages, things like kernel images, kernel headers, and kernel version-locked tools. And unattended upgrades can perform automatic reboots if the upgrade requires one. It can reboot with conditional checks to determine if users are logged in or not. It can also schedule reboot times if the upgrade requires one, using a 24-hour clock. And so to avoid resource contention, it can also throttle bandwidth when downloading packages, and rules can be defined for metered connections. It can define a downgrade policy for packages and their dependencies if it encounters pinned packages that cannot be upgraded. So unattended upgrades is exceptionally powerful, but one drawback is that it can be influenced and modified by root users on the machine. So this isn't suitable for regulated environments. So Landscape's upgrade profiles offer complementary controls to unattended upgrades, but scheduling, policies, and logging occur centrally on Landscape server. And this reduces opportunities for interference and obfuscation from local root users. So automated and manual patching capabilities have been native features in Landscape since its inception. The current Landscape release is Landscape 24.04 LTS, and it manages the previous 4 Ubuntu LTS releases. So management capabilities for this version extend back to Ubuntu 16.04 LTS onwards. And Landscape 24.04 LTS will also manage future Ubuntu releases, including Ubuntu 26.04 LTS and interim Ubuntu 24.10 and Ubuntu 25.04 and Ubuntu 25.10. So Landscape is available in 3 editions: as a self-hosted offering, through a software as a service model hosted on Canonical's cloud, and as a managed offering. The same source available codebase is responsible for each of these editions, And a new version of Ubuntu is published every 6 months, with a long-term support version that gets published every 2 years. And Landscape evolves with Ubuntu's cadence. So self-hosted Landscape can be installed from the beta or stable repositories. And Landscape beta is not intended for production use, but provides an early glimpse of new features. So when Landscape beta features mature, they are promoted from Landscape beta to Landscape SaaS. SaaS is an acronym for Software as a Service, and Landscape SaaS runs entirely in the United Kingdom data centers of Canonical's continuously upgraded global cloud infrastructure. Managed Landscape is deployed either on-premises or to any public cloud. And Managed Landscape marries the features of self-hosted Landscape with the convenience of Landscape SaaS, and is customized to meet any resiliency, redundancy, and high availability requirements. So this section will cover repository configurations for downloading security patches from a variety of sources. The Ubuntu Snapshot service makes it possible to see and use the Ubuntu archive as it was at any specified date and time. So snapshots of the Ubuntu archive are available for any date and time after March 1st, 2023. And so common use cases of this service include enabling reproducible deployments of a set of packages from a particular date and time, determining when a change in behavior occurred in the archive, and supporting a structured update workflow. For example, after a time-based snapshot of a package is validated in one environment, it can be released to other environments. So cloud administrators for larger Ubuntu estates will often need to test security updates and roll these gradually through their production fleet. And the continuously changing Ubuntu archive made it difficult to ensure that the updated packages that are tested in staging match those that are rolled out to each production instance. And Canonical's snapshot service at snapshot.ubuntu.com, coupled with Azure's integration of it, lets cloud administrators test and deploy a consistent set of updates all through a familiar cloud, or rather Azure interface. So this is the one-line format that Ubuntu has traditionally used for defining sources, where packages and updates can be downloaded from. So in this line, deb indicates the source line, and it refers to precompiled binary packages. It could be deb-src if it referred to source files. Snapshot equals yes is an option, and in this case, the option specifies that a snapshot repository is being used. The web address is just the URL of the repository at security.ubuntu.com/Ubuntu, and jammy-security is the suite. It is comprised of the distribution name, also referred to as a series name, and it's hyphenated with the pocket name. The security pocket contains the security patched binary packages in the Ubuntu Jammy release. And main restricted are two components of the suite from which packages can be retrieved. So main contains the official Ubuntu software that is free and open source, and restricted contains software that is not completely free in terms of licensing. So typically this includes proprietary drivers or firmware needed to enable certain hardware functionality. Now this is the deb 822 format being used in Ubuntu 24.04 onwards. This replaces the one-line approach that was shown on the previous slide. So you'll be able to use the Ubuntu Snapshot service for Ubuntu archives with unattended upgrades or Landscape. So Landscape can natively mirror Ubuntu archive snapshots locally, or configure machines to use a specific point-in-time snapshot hosted at snapshot.ubuntu.com. So we know where to get security patches from, but where can you deliver them from within your environment? So let's explore how security patches are organized when they're published on Canonical's cloud, and how they can be organized in your own self-hosted mirror. So Landscape Server will obtain information about bug fix and security updates from Canonical's cloud endpoint. It is possible to copy this information from the cloud or from physical media to the Landscape Server if the environment is offline or air-gapped or has other network constraints. Machines in your estate can be configured to download packages and updates from any accessible source. archive.ubuntu.com is the main repository for all types of software packages and general updates. So the purpose is, this is the main repository for Ubuntu packages. It hosts the vast majority of software packages available for Ubuntu, including the core operating system packages, libraries, utilities, and applications. It provides standard package updates, which can include feature updates, bug fixes, and non-critical security updates. And it contains various repositories, such as main, universe, restricted, and multiverse, which contain packages essential to Ubuntu, community-supported open source software that can be run on Ubuntu, as well as proprietary and other types of software packages. Security.ubuntu.com is a specialized repository for security-related updates and patches. So this repository is dedicated specifically to security updates, and its focus is on providing timely updates that address security vulnerabilities in the software packages available in Ubuntu. It provides critical security updates as soon as they are available, ensuring that users can quickly secure their systems against known vulnerabilities. And it primarily contains patched versions of packages that fix security issues. So these updates are prioritized to ensure the system remains secure. esm.ubuntu.com is where Ubuntu Pro subscribers obtain expanded security maintenance for their Ubuntu systems. So consider what is available in security.ubuntu.com. That's typically concerned with packages that go into building Ubuntu. Here you're getting packages from Universe as well. So security updates for packages that are in Universe in addition. So you get more and for longer with esm.ubuntu.com. Snapshot.ubuntu.com gives you a point-in-time view of archive.ubuntu.com and security.ubuntu.com. So we're working towards making snapshot.ubuntu.com work for esm.ubuntu.com. The only way to obtain snapshot.ubuntu.com-like mirrors of ESM packages is by mirroring esm.ubuntu.com on a schedule using a tool like Landscape. And livepatch.canonical.com is the endpoint, which distributes Livepatch packages to the Livepatch client. Livepatch client can be configured to use a self-hosted Livepatch server, which can be deployed to your own infrastructure or to a public cloud if you're choosing. And using the self-hosted Livepatch server, you can define availability zones, create distribution tiers, control phased rollouts, and go from, promote a patch from one group of machines to the next. If you do not self-host Livepatch server, then Livepatch client will randomly determine which cohort of machines you belong to and distribute Livepatch patches in phases that are programmatically determined by Canonical. So next we'll cover how security patches are distributed and how they should be applied and how long the security coverage is going to last. So Classic Ubuntu is a platform which provides non-atomic incremental updates. And this means the apt package manager replaces existing files and binaries, often in long interdependent chains. Ubuntu Core and its applications run within a confined and transaction-based environment. And everything in Ubuntu Core is a snap package, including the kernel. So security patching for Ubuntu LTS requires upgrades and reboots to be applied over time. Security is enhanced by enabling Livepatch, which is an Ubuntu Pro entitlement, and Livepatch does not reboot the machine and does not upgrade the kernel package on Ubuntu to the latest kernel package. Instead, Livepatch determines what kernel is running and security patches the kernel functions in memory without upgrading the installed kernel package. So applying the fixes in memory this way eliminates the need for a reboot. So Livepatch works on Ubuntu Core. The kernel is installed as a snap package on Ubuntu Core. And recall that snap packages can self-update. So when the kernel self-updates through the snap mechanisms, the device will reboot if it's running Ubuntu Core. The only way to security patch medium and below kernel vulnerabilities on Ubuntu Core is by updating the kernel snap package, which is going to reboot the device. So Livepatch will only patch high and critical vulnerabilities in the kernel, and it does so without rebooting the device. So the value proposition for Livepatch on Ubuntu Core is a deferred reboot when focusing on high and critical vulnerability protection, outside of the scheduled security maintenance window for the device. Many security updates can be installed and applied with a service restart, but security patches for certain packages make rebooting unavoidable. So Livepatch can secure high and critical kernel vulnerabilities without a system reboot or a service restart. But when running Livepatch, there is no downtime impact associated with its security patching activities. However, Livepatch does not address medium and below kernel vulnerabilities. So installing the security patched kernel package and rebooting Ubuntu is required to patch those medium and below vulnerabilities. So the GA kernel, or the general availability kernel, is shipped with Ubuntu and is the most stable and cost-effective option for environments where hardware doesn't change after provisioning the operating system. Customers who need the latest hardware support capability can install the latest HWE kernel, or hardware enablement kernel. But the security patching lifespan associated with HWE kernels is 9 months. And with a 6-month release cadence, this gives users a 3-month window to upgrade to the next HWE kernel without encountering a lapse in security coverage. So the timeline at the top shows how you can get to the HWE kernel that is also a GA kernel in a future release with the fewest upgrades and reboots as spaced out as possible. The timeline at the bottom shows you how you can get on the HWE kernel with comfortably spaced out upgrade and reboot intervals. So Ubuntu Server on public cloud and Ubuntu Desktop are on HWE kernel tracks, and Ubuntu Server anywhere else is on the GA kernel track. To launch Ubuntu Desktop on the GA track, deploy Ubuntu Server and install the Ubuntu Desktop meta package. Weekly security patching and reboot cadences are recommended, and a daily regimen is applauded. But monthly security patching and reboot cadences can work well because there is no chance of running a stale kernel when running a monthly security patching schedule. Biannual security patching and reboot cadences will also work if you perform security patching and rebooting between February and May and between August and November. But if your biannual security patching and reboot cadence happens between January and February, and then again between June and July, you're missing our releases and running stale kernels for portions of the year. So how does Canonical's kernel rolling strategy impact security coverage duration? We've hinted at what some of the problems could be in the previous slide. So let's look at kernel rolling strategy in closer detail. So kernel versions from the subsequent 4 releases of Ubuntu are made available on the latest Ubuntu LTS. As mentioned earlier, the kernel versions are incremented in Ubuntu LTS dot releases numbered 2 through 5. And these occur on a regular February and August cadence. This February and August release cadence should play a role when planning upgrade and patching cycles for a fleet of Ubuntu LTS machines. Before making a patching cadence recommendation, let's consider constraints and opportunities provided by Livepatch as well. So Livepatch provides 13 months of security patching coverage for the GA kernel, and users interested in transitioning from the HWE track have to decide if they want to upgrade to an HWE kernel after 11 months, once the .2 release is available. This decision must be made between February and May, but an upgrade and reboot has to happen by the 13th month for the GA kernel. If you stay on the GA kernel, you are required to upgrade and reboot every 13 months. The upgrade will patch all vulnerabilities for the GA kernel, and the machine will reboot into the updated GA kernel. If you opt to use the HWE kernel, your upgrade and reboot window shrinks. The .2 through the .5 Ubuntu LTS releases occur in a 6-month cadence. So Livepatch provides security patching for the .2 through the .4 releases in 9-month chunks. So there's a 3-month buffer between the upgrade being available and your live patch coverage ending to perform an upgrade and reboot. An upgrade and reboot has to happen by the 9th month for these HWE kernels. Now, Livepatch provides security patching for the .5 release in 13-month chunks because it is also a GA kernel in another Ubuntu LTS. Therefore, upgrades and reboots don't have to happen until the 13th month. It gets more complicated when transitioning between GA and HWE kernels because your maximum upgrade and reboot cadence alternates between 9 months and 13 months. So scheduling upgrades and reboots every March, May, September, and November seems pragmatic based on what we see in this table. We distribute security patches as soon as they're available and without any delay. And we also include ratings for severity and priority in our notices. So this gives you full control over when to patch your estate. Now, the Ubuntu security team will triage and assess whether an update is a significant security issue. And security updates are placed in the security pocket first. The kernel team uses those security updates as a basis for the Livepatch implementation. The security team also publishes CVEs, which are unique IDs for cataloging vulnerabilities. And when patches are published, the security team associates the patches to Ubuntu security notices and Livepatch security notices. And these get published on ubuntu.com/security/notices. The security team patch the highest version of the package from either the updates pocket or the security pocket. They release this patched version to the security pocket. As such, the security pocket can end up containing some changes from the updates pocket. And this is necessary to ensure all users, including those using the updates pocket, can always upgrade to the security updated version. So Canonical adds no delays in the delivery of security updates. And we provide you with tools to define cohorts of machines through any combination of availability zones, tags, groups, or custom metadata to deliver the updates to a selection of machines in your estate. So Landscape can help you test your patch rollout and promote patches from one environment to the next. But looking beyond our zero delay security patch publishing process, it's also worth considering the Ubuntu release cycles and other scheduled in advance upgrades from Canonical. These should play a role in influencing your security patching and reboot schedules. So knowing exactly when major updates to Ubuntu are happening will help you craft a sensible patching schedule if you're unable to apply security patches right away. So let's do some quick calendar math and figure out when to schedule upgrades and security patches. There are typically 5 point releases for every Ubuntu LTS. And these point releases have improved compatibility with modern hardware and include all the updates. So point releases save time by not requiring big patch downloads. The first point release arrives 4 months after the April release, and then in 6-month intervals, every February and August. The 5th dot release is typically the last. The first dot release of an Ubuntu LTS always coincides with the 5th dot release of the preceding Ubuntu LTS. Each Ubuntu interim release offers a preview of the next Ubuntu LTS point release and the next Ubuntu LTS. These interim releases arrive in 6-month intervals between the 2-year Ubuntu LTS releases in April and October. The 4-month offset for the Ubuntu LTS point release provides time to collect bug reports and feedback from Ubuntu interim release users. And the kernel version from the Ubuntu interim release is made available in the subsequent Ubuntu LTS point release for anyone interested in using it. The kernel version included in Ubuntu LTS on release day is called the General Availability Kernel, also the GA kernel. And Ubuntu server installations are going to stay on that GA kernel by default. And the GA kernel is supported and security patched until the end of your Ubuntu Pro coverage for that Ubuntu LTS. So this table illustrates this rolling kernel model and explains how the HWE kernel is made available in Ubuntu LTS point releases. The first point release never includes a new kernel. The subsequent 4 point releases include a kernel upgrade by including the kernel version from the preceding Ubuntu release that happened 4 months before. The February point release gets the previous October's kernel. The August point release gets the previous April's kernel. There is a deliberate overlap between the new Ubuntu LTS version and the final release of the previous Ubuntu LTS version. So to phrase this differently, the 5th point release of every Ubuntu LTS happens after 2 years and 4 months. The 5th point release always has an Ubuntu LTS as its preceding Ubuntu release. So this is how a GA kernel version in an Ubuntu LTS becomes the HWE kernel version for its preceding Ubuntu LTS. And backporting the kernel this way provides excellent long-term value and provides a clear path for upgrading from one Ubuntu LTS to the next. So to recap with real numbers from an actual Ubuntu release, I'll summarize this table from left to right. Ubuntu 20.04.1 saw no kernel changes, which is expected for the first point release. Linux kernel version 5.8 was used by Ubuntu 20.10 and is available in Ubuntu 20.04.2. And Linux kernel version 5.11 was used by Ubuntu 21.04 and is available in Ubuntu 20.04.3. And Linux kernel version 5.13 was used by Ubuntu 21.10 and is available in Ubuntu 20.04.4. And Linux kernel version 5.15 was used by Ubuntu 20.04.0, which is an LTS, and is available in the 5th point release of Ubuntu 20.04. So now we have a clear view of release schedules, but how does this influence your security patching? So security patching for Ubuntu LTS requires upgrades and reboots to be applied over time. And security is enhanced by enabling Livepatch, the Ubuntu Pro entitlement, but Livepatch does not reboot the machine and does not upgrade the kernel package on Ubuntu to the latest GA kernel. Livepatch does apply the security patches in memory, and therefore it doesn't require a reboot. So the GA kernel is patched incrementally until its associated Ubuntu LTS reaches end of life. And security patching coverage for the GA kernel is provided through Ubuntu Pro's expanded security maintenance, commonly abbreviated as ESM. Security patching coverage for the GA kernel is provided through Livepatch in a sliding 13-month window. So booting up with a recently security patched GA kernel extends the 13-month Livepatch window from the date the updated GA kernel was published. Before this 13-month window expires, Ubuntu must be upgraded and rebooted into a newer, incrementally patched GA kernel. These conditions for Livepatch security coverage are illustrated by the required reboot icons and the red line. So I'm going to read this visualization from bottom left to the top right. If you see a required upgrade and reboot symbol, look to see if a new HWE kernel has been published above that symbol. So Livepatch provides security patching for 9 months from the date the HWE kernel is published. On or before the expiry of this 9-month window, the Ubuntu instance must be upgraded and rebooted to prevent a lapse in security coverage. So unless the GA kernel is manually installed, Ubuntu desktop and public cloud virtual machines will be running on the HWE kernel track. The security coverage for both the 5.11 kernel and the 5.13 kernel expired within 2022, which would have caught organizations with an annual security patching cadence flat-footed. This will always happen in the 4th release of every Ubuntu LTS, which is available in February, but no longer getting security coverage after November. This event requires an upgrade and reboot twice in that single calendar year. The 5th release of the LTS is special because the final HWE kernel is also the GA kernel for the next Ubuntu LTS release. So for this reason, the 5.15 kernel carries the same 13-month Livepatch coverage window as the 5.4 GA kernel. Outside of the 3rd year of an LTS, when the 4th release is published, it is possible to apply security patches once a year. However, this annual patching activity cannot be performed in the same month, year after year, without experiencing a lapse in security patching coverage. So given the constraints illustrated by this timeline visualization, it may be more trouble than it's worth to pursue an annual patching cadence, but that's for you to decide. I want to draw the distinction between what is required and what is recommended. And applying security patches in one-year intervals can work, but Livepatch is only addressing critical and high security vulnerabilities. One-year intervals leave your system exposed to security vulnerabilities rated medium and below. So until the upgrade and reboot is performed, you're not having the safest security posture that you possibly could have. Upgrading and rebooting the machines with the GA kernel every May and September improves your security posture. The HWE kernel is released every 6 months, but is security patched for 9 months, providing ample time for upgrading. And security patching for the HWE kernel is provided by Livepatch for a 9-month window. So booting up into the currently published HWE kernel extends the 9-month Livepatch coverage window from the date the updated HWE kernel was published. So on or before the expiry of this 9-month window, Ubuntu must be upgraded and rebooted. And these conditions for Livepatch security coverage are illustrated by the required and recommended reboot icons and the red lines. So it bears repeating that Livepatch does not reboot the machine and does not upgrade Ubuntu to the latest HWE kernel. And unless Ubuntu desktop or public cloud virtual machines are manually configured to use the GA kernel, upgrading and rebooting these machines is all that is needed to use the latest HWE kernel. So upgrading and rebooting machines every May and September will ensure that there is no lapse in security patching coverage from Livepatch. So this table represents both the GA and HWE experiences on a single timeline for Ubuntu 20.04 LTS. So study this table and see if you can figure out what GA kernel Ubuntu 22.04 shipped with. So from this table, you know that 20.04.5 release included kernel version 5.15. Therefore, the next Ubuntu LTS after Ubuntu 20.04, Ubuntu 22.04, shipped with Linux kernel 5.15 as its GA kernel. The 5th point release for Ubuntu 22.04 is published in August 2024, and it includes version 6.8 of the Linux kernel. The Ubuntu release preceding the 5th point release for 22.04 is Ubuntu 24.04, which was published just recently in April 2024. So Ubuntu 24.04 LTS with codename Noble Numbat shipped with the Linux kernel version 6.8 as the GA kernel. Well, we don't know what kernel versions will appear in the dot releases in the future. We know exactly when those upgrades are going to be available. And now you also know the recommended and required upgrade and reboot intervals. So enabling Livepatch and upgrading and rebooting biannually every May and September will keep you safe, but monthly, weekly, or daily upgrade and reboot cadences will provide even more protection. So to recap, and apologies for running a couple of minutes over here, best practice number 1, limit your exposure window. More frequent security maintenance windows are obviously better, and now you can make an informed plan to protect your estate when scheduling fewer security maintenance windows in a year. Best practice number 2 is consider security coverage durations for Ubuntu and the underlying bits, such as the kernel. So don't plan a maintenance cadence which results in workloads running software that isn't covered through security patching automations like Livepatch. Remember the plight of the person performing annual security patches in the 3rd year, and then during the 4th dot release of the Ubuntu LTS. So the annual security patching routines resulted in software running without any Livepatch coverage for several months. And if your biannual security patching and reboot cadence happens to be in January and February, and then again between June and July, you're missing our releases and running unpatched kernels for portions of the year. So let's recap what will work. Biannual security patching and reboot cadences will work if you upgrade and reboot between February and May, and then again between August and November. May and September are the best times of the year if you are using Livepatch and need biannual security patching. Monthly security patching and reboot cadences can work well. There is no chance of running a stale kernel when upgrading and rebooting monthly. And weekly security patching and reboot cadences are recommended, and a daily security patching regimen is applauded. So take maximum advantage of security patches as they are made available by running your workloads in high availability and enabling security patching automations to protect your machines as they go through the phased upgrades and reboots. And best practice number 3, enable patch automations. Enabling automations like unattended upgrades require closer inspection of reboot configurations, since reboots are an essential component for completely applying some security patches. Enabling automations like Livepatch is a brilliant move, but without unattended upgrades or landscapes upgrade profiles running in conjunction with Livepatch, medium and below vulnerabilities could remain unaddressed for longer than is desired. So now that you've all had a drink from the information fire hose, there may be some outstanding questions about Ubuntu, landscape, and Livepatch. And so time permitting, this is an excellent opportunity to dive into questions. So take a moment to type up your thoughts, and I'm going to take a look at what we have queued up. Let's see. All right, we have an excellent question. How do Livepatch updates in memory show up in vulnerability management solutions? And so vulnerability management solutions should be probing the Canonical Livepatch package to see what LSNs have been applied on that machine. And the Canonical Livepatch package will provide machine-readable outputs. It can format the outputs in YAML or JSON. Soon, Landscape is going to be consuming these outputs as well, and you're going to start seeing LSN information surfaced natively inside of Landscape. And it would be great to see other dashboards begin surfacing Livepatch information as well. Okay, there's another question here. Is there functionality to turn off all patching processes in a production server? Our plan of patching is to use our dev environment to do patching, and then once we are happy that no patches broke anything, we will then use apt to install all patches on the production server. Is this a viable process? So absolutely. If you wanted to have manual control over everything, you can disable unattended upgrades. You don't have to configure landscapes upgrade profiles. And you can use repository snapshots to promote your patches from one environment to the next. On the flip side, if you were to enable some of these automations, but the sources of truth were where you applied the brakes and then controlled where upgrades are coming from, you'd be able to turn on the automations and then roll out the updates using those automations. I'll give you an example. If you wanted to have upgrade profiles enabled and have unattended upgrades also enabled, and then you changed the repository configurations on that machine to only fetch packages from a particular point in time, you now have the benefit of having those automations enabled, but you're downloading the security patches and the software updates from a particular point in time. So you could do it both ways, but my recommendation would be to have the automations turned on and then fetch from a point in time repository snapshot. But there's nothing wrong per se with doing it the other way around by disabling all of the automations and manually triggering the updates. And Landscape can help you do it that way as well if you wish. Another question here is there any rationale to run a full patching system on-prem versus remote? I can do either, but I feel like the on-prem gives me more control. And one of the main benefits of mirroring all of the repositories and security updates locally is that if you are distributing to many machines internally to your network, and if you don't want all of these machines to be going out over the internet to retrieve their updates, it does make sense when you've got network constraints or just from a distribution performance perspective. I think there's another question here. Livepatch alone does not keep a system fully patched or protected from security vulnerabilities, but with Landscape, we can schedule the patching and rebooting. What I think that question means to ask is, with Livepatch, we're only getting the critical and high vulnerabilities getting patched, but with Landscape, we're able to get the entire spectrum, high all the way down to low. With Landscape, you can manually trigger reboots across a selection of machines. We have not yet implemented reboot profiles into Landscape, but there's nothing stopping you from configuring the reboot capabilities that are available in the unattended upgrades package and configuring unattended upgrades from Landscape. So it may feel like you're jumping through a couple of hoops to get this reboot profile applied to a selection of machines, but there will be a more native way of doing it from within Landscape in a future version of Landscape. Another question is, would it be correct to say that monthly patches are adequate for the latest security patched kernel? So yes, if you were to be installing your security patches on a monthly basis, that is certainly one way to stay secure. But it's worth noting that just installing the package alone is not enough. In order to benefit from running the latest package that you have installed, you do need to reboot the machine. So I would stress that it's necessary to install and reboot the machine to benefit from all of the security patches that you are installing. Another question is the snapshotting ability in Landscape able to provide different repositories to different groups and classes of clients? For example, development, staging, and production. And the answer to that is yes. You can divide up your estate into different access groups, and then you can associate a particular repository profile, which is a selection of repository configurations, to machines in a specific access group. So if you wanted to change the repository configurations for a group of machines, you could do that. Another question here is, we're new to Landscape. Is there a best practice guide to using Landscape and upgrade profiles? I haven't had a lot of luck finding documentation for Landscape. Well, I'm sorry to hear. We've hired a technical author that is helping us with our Landscape documentation, and she has done a phenomenal job. And the latest documentation can be found at ubuntu.com/landscape/docs. With regards to best practices, I try to share recommendations in webinars like these and don't provide prescriptive rules for how things should be done within the documentation. The documentation is more to serve as a source of information for people to assemble their patching routines in the way that they feel is best. But if you have any specific questions with how things should potentially be set up and organized, feel free to give us a call or reach out to us. And there are subject matter experts that can work with you and then talk with you about what your requirements are, what your deployment looks like, and come up with a plan that makes sense. I want to thank everybody for staying the extra time and making it to the end, and then also for participating in the Q&A section. This was a lot of fun. I enjoyed taking in your questions, and I look forward to seeing you folks in the next webinar. Take care.